All right. Well, good morning. My name is Philip Kennel, and I'm the chair of the ASTM International F-38 Committee on Unmanned Aircraft Systems. And today I'd like to talk about the U.S. and global regulatory landscape and the impact of standards to support the safe integration of unmanned aircraft systems into the national airspace of any nation. There we go. But first, I'd like to talk a little bit about ASTM International. ASTM is one of the world's largest standards development organizations, and we work across the globe to promote a range of activities in support of many global industries. ASTM was in fact established in 1899 to support transportation in the railroad industry. And since then, we have been developing trusted, relevant, and high-quality industry consensus standards in more than 150 nations. ASTM has over 30,000 volunteer members representing the public and private sectors as well as academia. We have almost 150 committees with over 2,000 subcommittees, and we address standards in just about every industry imaginable. Our headquarters are in Philadelphia, Pennsylvania, and we have international offices in Beijing, Brussels, Lima, Ottawa, Singapore, and Washington, D.C., where I am currently based. We have a very broad aviation portfolio with standards committees to support aviation in 6 different areas. First, we have F-37 light sport aircraft. We also have the committee that I'm in charge in, F-38 for unmanned aircraft systems, and F-39 aircraft systems in general, which supports all of our aviation sectors, and F-44, the general aviation aircraft committee, which now is deeply involved with urban air mobility and advanced air mobility aircraft, including eVTOL or electric vertical takeoff and landing platforms. And F-46 is our aerospace personnel, which supports the training of aerospace personnel across the aviation community. And our newest committee, F-47, commercial spaceflight. We also have a training and certification program and a light sport aircraft personal certification program. In addition, in the lower corner in blue, you see other committees that we have that can support the development of aviation standards. But first, let me talk a little bit about F-38 Unmanned Aircraft Systems, the committee that I currently lead. We were formed in 2003 at the request of the FAA. We currently have over 600 worldwide members, to include 30 regulators from several countries. And we have 26 approved standards and 25 currently under development. The committee is broken down into 3 separate subcommittees: airworthiness, flight operations, and personnel training and certification. These 3 committees we like to think of as hardware-oriented and now software-oriented. Our flight operations committee is really based on procedure-oriented to include infrastructure, which I'll talk about a little bit later, and personnel training and certification, our people-oriented subcommittee. We also are developing standards which cover infrastructure. These 3 categories, airworthiness, flight operations, and personnel, are only good if you have the infrastructure that you can fly these aircraft in. So we're now developing standards to support UAS traffic management, as well as vertiport design and operations. Let me talk now about some of the key standards that the committee has developed that are supporting the integration of aircraft, and also some of the regulatory activity that generated these standards. The FAA currently has a regulation in place, which is Part 89, which requires that all UAS comply with a remote ID and tracking capability. We developed at the FAA's request a standard F4311 for remote identification and tracking. And this standard has pretty much had a global impact in its early days. And it was an outcome of the FAA's Aviation Rulemaking Committee, which acts in advisory capacity before rulemaking actually takes place. We started this standard in advance of any rule at the request of US regulators to determine what was feasible, practical, and affordable before publication of any regulation. And one guiding principle was the ability to be compatible with a common handheld device and to ensure that it was not a technology that used ADS-B, which the FAA considered out of scope because of the fact they thought it might clog up the radar screens of air traffic controllers if thousands of UAS were flying around transmitting ADS-B. So we decided on a standard to broadcast what we call an electronic license plate signal using Bluetooth or Wi-Fi technology compatible with most handheld devices, which can be smartphones or tablets. And there are actually three ways that drone pilots can meet the remote ID rule. The first way will be standard remote identification with the technology already built into the drone during the manufacture of that drone. The second way is remote ID broadcast modules, which can be attached to legacy aircraft built prior to the required manufacturer's date. But these aircraft will be restricted to visual line of sight operations only. And the third category are for those legacy aircraft, such as model aircraft or recreational aircraft that do not comply with the regulation. And they are restricted to operating only in designated community sites, which the FAA calls FAA recognized identification areas or FRIAs. So in the US, we've already been working on a means of compliance for remote identification with the FAA. But this slide shows a demonstration that took place in Switzerland using the standard to show the successful application of the remote ID standard and the protocols for remote ID using both broadcast and networked capability for remote ID. And this just shows the variety of devices that the standard was able to be compatible with. And what they were also looking at is the remote ID network capability as a foundational element for UAS traffic management. The remote ID standard that ASTM published is currently being adopted on a voluntary basis in Switzerland and will be adopted as a means of compliance in the European Union, Japan, and the United States by regulation. We're also working on a revision to the standard to ensure that it complies with all the regulatory requirements of those civil aviation authorities. In fact, ASTM provided the European Standard Organization, ASD Stand, our standard for them to publish in Europe so that we'd have international harmonization of the remote ID standard and capability. And also recently in the United States, the FAA amended the Part 107 rule for small UAS. Now, this Part 107 rule was really the lowest bar for UAS operations. It permitted operations generally in visual line of sight. Anything more than that would require a waiver. But the amendment to the rule recently allowed for operations over people and night operations without requiring a special waiver, as long as the UAS operator met certain requirements. For operations over people, the requirements are based on potential injury impact due to kinetic energy, and it was divided into 4 categories. Additionally, all the aircraft operating over people had to have no exposed rotating parts. So for very small aircraft weighing less than 250 grams, operations over people are permitted, since it assumes that the impact of these very small aircraft will have a very low risk of injury to anybody that it hits. For aircraft over 250 grams, operations are permitted if the operator can demonstrate that the kinetic energy impact does not exceed 11 foot-pounds or about 14.9 joules of energy. And kinetic energy transfer is permitted up to 25 foot-pounds or 33.9 joules under restricted access events or with permission of the participants. So these events are something like a movie set operation where actors and support personnel are being exposed to a unmanned aircraft system, and they've given their permission for those platforms to fly over them during filming. And for certified aircraft, operations over people are permitted unless specifically prohibited under the flight manual. So in the United States, a certified UAS is allowed to fly over people without having a waiver. And then for night operations are now permitted in the United States, but it requires that the operator take an additional knowledge test or training, and that the lighting on the aircraft has to be seen for 3 statute miles. Now, in accordance with this regulation, ASTM F-38 committee published a standard called F-3389, which is the standard test method for assessing the safety of small unmanned aircraft impacts. And this standard outlines different analytical and test methods to comply with the regulation. ASTM is currently working on a means of compliance for this standard with the FAA based on the operations over people. And we expect to have that complete in about 4 more months. So this standard, additionally, we've published a small UAS parachute standard that mitigates the risk of operations over people. And the standard is F-3322. And with the successful deployment of a parachute on a small UAS, it would lessen the kinetic energy impact on an individual that it hit. So this standard ties in the durability and reliability of the design of the system itself and outlines the accepted means in the event the aircraft fails in a variety of configurations, ensuring the successful deployment of the technology. So this can be used to reduce the energy impact of a UAS and therefore meet the requirements of the rule. And we've had this tested many times at various test sites around the United States and Europe to ensure that this standard will actually support reducing the kinetic energy impact of a small UAS. Now, the next big thing that we're looking at as far as regulation and standards and in the regulatory landscape will be the outcome of the FAA's Aviation Rulemaking Committee for Beyond Visual Line of Sight operations. And I think this is what's going to be required for the successful commercialization of small UAS and drone operations in general. And the goal is to make beyond visual line of sight operations safe, routine, and commercially viable. And we'll cover the beyond visual line of sight requirements for, in this case, for this specific ARC rulemaking. It's looking at linear inspection, small package delivery, and precision agriculture. We expect this will be only one of many rulemaking committees to address other categories of beyond visual line of sight operations. The rule specifically will not cover passenger carrying drones or aircraft under air traffic control. In support of the beyond visual line of sight, ASTM has also developed a detect and avoid standard, F3442, which defines the minimum performance standards and test methods for detect and avoid systems and sensors applicable to small UAS operations in the lower altitude. So we're looking at smaller, not small UAS, but UAS generally under 254 pounds and could have wingspans up to 21 feet. And for UAS operations in lower altitudes, and in this case, we consider lower altitudes, 1,200 feet AGL. And the standard defines the performance requirements for detections of manned aircraft to UAS encounters, not UAS to UAS encounters. And we expect that this standard will be required to inform future beyond visual line of sight standard practices. So what's the next step for the FAA's beyond visual line of sight ARC? The ARC, which is made up of industry, academic, and association stakeholders, of which ASTM is also a member, will initially make recommendations to the FAA. We expect that to occur next month in January of 2022 when we complete the work on the recommendations. The FAA will then look over the recommendations and consider them as they develop the new rule. And then after the rule is published, ASTM will address the performance-based standards as a means of compliance to meet any regulatory requirements that come out of this standard. So what we're doing now in F38 is we're also anticipating some of the outcomes of the ARC. And for the past 2 years, we've been working on a comprehensive beyond visual line of sight standards roadmap. And the way we do this is we formed an administrative committee, AC 478, which specifically does not develop the standards themselves, but makes recommendations to other technical committees in ASTM to develop the standards. So the 6 committees that we identified earlier in this briefing, the aviation committees, are all working together on beyond visual line of sight roadmap or strategy to address the potential outcomes of the rulemaking committee. And what we're going to consider success is having routine commercial operations that are enabled through a clear and accepted standards-based path to beyond visual line of sight operations. So during this road mapping process for beyond visual line of sight, the committee identified 20 essential functions to support beyond visual line of sight. The first one to come out of the AC 478 committee was a standard for position, navigation, and timing, which is now under development. The committee felt that knowing exactly where your aircraft was at any given time was fundamental to ensuring safe operations of beyond visual line of sight. So this was the first one of many that we'll be tackling at ASTM to support BVLOS operations. Now, one of our most recent approved standards was in support of UAS traffic management, and that was just approved December 1st, and that is F3548. And this is one of many standards that will be supporting beyond visual line of sight operations and also package delivery, ensuring safe operation in congested airspace in the future. The standard sets up the communication architecture and protocol for communication between UAS service suppliers. We've also decided to expand the standard in the next version to include urban and advanced air mobility operations for passenger carrying electric vertical takeoff and landing aircraft. So we see that a lot of the lessons learned and protocols that we put in place for UTM traffic management will also be applicable in the area of urban and advanced air mobility traffic management. And the key here is to ensure a safe connection between UTM, ATM, and the ATM infrastructure. And we feel that developing urban air mobility traffic management protocols will assist in that. So one other key standard, I've talked about a little bit about the architecture required and what we're going to do for beyond visual line of sight. But one challenge that a lot of UAS manufacturers have had over the last few years is developing an airworthiness standard for smaller UAS aircraft, which don't have the ability to put a lot of technologically advanced systems on a platform, such as a very large platform that can put a lot of avionics on board. So what the FAA came up with was a process called durability and reliability. And so what they asked ASTM to do is develop a test method to ensure durability and reliability of small UAS. And so those are generally UAS that are less than 55 pounds. And in that, we looked at this as being one of the first steps for some of the package delivery aircraft to certify their platforms, since in the United States, anything that has to do with commerce or transport of goods has to be a certified aircraft. So we developed a durability and reliability test method. And this method is an alternative to the traditional airworthiness certification processes for those lower risk unmanned aircraft to demonstrate their airworthiness. So the aircraft would have to demonstrate the durability and reliability of that platform, and the requirements would be much higher in the higher risk environments that they'll fly in. So if they're going to fly in a rural area with less infrastructure and people around, then the requirements are going to be a little lower, the reliability requirements. As they fly into congested and urban areas, the design and failure requirements become much more rigid. And with that, my presentation is ended. And because this is a virtual presentation, I guess there are not going to be any questions. But if anybody does have any questions or follow-ups, there's my contact information. Please feel free to contact me with any questions, and I'll get back to you as soon as possible. Thanks very much for having me here, and I hope you have a wonderful conference.